Welcome to Easy BTech, your guide for BTech and beyond. In this video, learn about the surge impedance. Surge impedance ZS. Okay. This surge impedance is also called characteristic impedance. It is also called characteristics impedance, or it is also called natural impedance. Natural impedance. How we can calculate this surge impedance of a transmission? We have an expression in long transmission line derivation, ascending and voltage and current expressions. We have a term root of Z by Y. From this term, we can evaluate the surge impedance. Okay. We know this term, it is called a ZC or a ZS equals to root Z by Y. Okay, what is Z? Z equals to R plus J omega L. Y is G plus J omega C. If the transmission line is a lossless line, transmission is a lossless line. The losses in the overhead transmission system, or whatever it may be the transmission system, due to only resistance and conductance. For making lossless transmission line, we have to make R and G, both the terms, resistance and reactance terms, are 0. Therefore, this resistance is going to 0 and inductance is going to 0. J omega by J omega, then we can get this surge impedance or characteristic impedance or natural impedance is root L by C. One thing here we have to observe in surge impedance is it is not depending upon, depends upon length of the transmission. It is not depending upon. Keep in mind, it is very important for competitive exams. So they will provide the surge impedance of a 50 kilometers transmission line is 40 ohm. Then what is the surge impedance for 100 kilometers? There is no change in surge impedance because it is not depending upon the length of the transmission line. Again, it is also 40 ohm. Okay. We will define this surge impedance. The surge impedance is nothing but the surge impedance. It is the impedance offered to the propagation of voltage or current waveforms. Voltage or current wave during its travel along the line. Okay, for suppose assume that it is a overhead transmission system. A surge is initiated here. Then surge having with voltage and current waveforms, whatever it may be, the flowing through the transmission line. This transmission line offers how much impedance to that particular wave. That impedance is called surge impedance. Can be calculated inductance and capacitance of that particular transmission line. That is called surge impedance. Okay. Now this surge impedance values. The surge impedance value is calculated from root L by C. This value is 400 ohms approximately for overhead transmission lines. This value is 40 ohm for underground cables, because in underground cables the capacitance effect is more than the surge impedance is less. That's why the surge impedance value is less. For transformers, we have several thousands, because the transformers having more inductance. If inductance is more here, if the inductance is more, then automatically the surge impedance is more. That's why in transformers we are having several thousands of impedance. Okay, this is about surge impedance, and next we will see surge impedance loading. Surge impedance loading. Short form, it is write it as SIL, surge impedance loading. Okay. Now, okay, here we will discuss the surge impedance loading. Short form, it is SIL. Okay. Surge impedance loading is power loading of transmission line when the line is lossless. That is called the loading of the transmission line. The loading of lossless transmission line is called surge impedance load. Suppose the transmission line produces reactive power, MVAR produced by the line, VAR produced by the line. We can calculate it from V square by XC. Okay, how much reactive power generated due to the capacitance effect of the transmission line, and the reactive power absorbed or used by the line. Okay, it is depending upon how much amount of XL value. Okay, I square XL. Okay, now under this surge impedance loading condition, under surge impedance loading, MVAR produced due to the capacitance effect is equals to MVAR used or absorbed by the transmission line under this surge impedance. MVAR produced is V square by XC, and MVAR reactive power absorbed by the transmission line is I square into XL. Okay, therefore from this, XL into XC equals to V square by I square. It is V by I whole square. Therefore this XL and XC value, you know, XL equals to 2 pi of L into 1 by 2 pi FC is equals to V by I whole square. 2 pi f1, 2 pi f get cancelled here. 2 pi f get cancelled. The remaining is L by C equals to V by I whole square. From this, V by I equals to root of L by C. What is voltage by current in AC circuits? We know that that is nothing but impedance. Therefore, surge impedance equal to root L by C. We can calculate the surge impedance from this case also. Okay, now how we can evaluate the surge impedance loading? The surge impedance loading is not about the information how much it can having the capability. Okay, it is not giving that information. We can calculate the surge impedance loading is line to line voltage square divided by ZC. Okay, this is the formula for surge impedance loading. we can, what the information we given, the actual loading on the line, loading on the line is greater than surge impedance loading, greater than surge impedance loading, then it requires reactive power. Then we have to connect a shunt capacitors. If loading is greater than SIL, it is operated at under a lagging power factor. Okay, we have to improve the power factor. We have to connect the capacitor also. We have to take in this case also. By connecting this shunt capacitors, we can improve the voltage profile. We can improve the voltage profile of the line. Okay. If loading on the line is less than surge impedance loading, then it is producing more reactive power. It is reducing more reactive power. To absorb that excess reactive power, we have to connect a shunt reactors. By connecting the shunt reactors, it can reduce the charging current of the transmission. Line. Okay. Now, the surge impedance loading compared with the actual loading on the transmission line gives whether the transmission line produces the reactive power or absorbing the reactive power. Okay, this information is very important. And also, if loading is less than the surge impedance loading, it produces more reactive power. If at the receiving end we are having more reactive power, then receiving end voltage is greater than sending end voltage. Okay, this is also one of the information from the surge impedance loading. If you know the surge impedance loading, then according to that, the loading on the transmission line is either greater than the surge impedance loading or less than the surge impedance loading. We have to compare with the SIL. Okay, thank you very much for watching.